Hey, welcome back. So we're doing 37 silver, and this is about degree and end behavior. So the definition of the degree of a function is the largest exponent of the variable. So the largest exponent. Right, so if I'm looking at this equation here, on the x there's no variable, which as we can remember means that the variable is, or the exponent is 1. So the degree here is 1, and this graph just looks like a linear function, right? And we can see that it goes up straight. The degree in the second one here is the biggest exponent is 2. And what that looks like is the quadratics that we've been used to, or the parabolas, right? We call this quadratic, right? Very simple. Will always look like that. It may look upside down like this if it is negative in the beginning. We have here a degree of 3. This is a new graph for us. It's called a cubic graph. They look like this, and it's called cubic. And then finally, we have the degree of 4, and that graph looks like a W, something like that. And that is called a quartic graph, right? Just like 4 quarters, quartic means 4 degrees. So both the cubic and the quartic can be, well, we would see them as upside down, right? Have the same general shape, just like that. So that's our degree, very simple. And then finally, we have our end behavior. And end behavior defines what happens to a graph at the end. So it happens to a graph when x gets really big, either really big or really, really small. Right, so basically what happens when we go to the left side of the equation or to the right side of the equation. So we have a table here, and let's just take a second to look at it. So what's happening in this box is we are talking about when we have a leading coefficient that's greater than 0. So what that means is the function is positive. So it's like x squared, or x to the third, as we can see here. Here's x to the third, and the function is an odd degree. So this means that we have x, or x to the third, or x to the fifth, or x to the seventh, or x to the ninth, right? So one of those graphs, it's going to ultimately be up and down like this, okay? So what this means, we have some like funky notation here, but what this means is that as x goes to negative infinity, so if we're thinking about it on our x and y axis, as x goes this way, right? Let me clear up some space here really fast. So as x goes this way, we're wondering what happens to the graph. And what's happening to the graph is that the graph is going down. So we would also say that y is going to negative infinity, right? What this says here is as x goes to positive infinity, so as we go this way, we want to know what happens to the graph. And what's happening is that it's going up. So y is also going to infinity because our y's increase as they go up. Right? So when the leading coefficient is negative, right, or less than 0, what that means is our graph flips over like this. Right, so we start at a different place. So as we're going in this direction, right, so as we're headed to the left, that is when x is going to negative infinity, right, because our x's are counting down, right, they're like 0, -1, -2, -3, oh boy, there we go. -1, -2, -3, -4, -5, -6, -10, etc., etc., right? As our graph is going this way, what's happening to our equation is that the y's are increasing. So we would say y is going to positive infinity, right? We can look at this a different way when we are headed in the positive direction. So when y is going to positive infinity, we would say that the y's we see here that they're going down, right? So that would be y going to negative infinity. It's decreasing, -1, -2, -3, -4, -5, etc., etc. Right? So those are odd degree functions. I'm going to draw both of our even degree functions. So an even degree function generally looks something like this. Might have some squiggles in the middle, but we're just worried about what's happening at the end here. Right, so at the end, this is when the graph is positive, so maybe x squared, maybe x to the fourth, right? That's when it's positive. And then what happens when it's negative is it looks like this. This might be negative x squared or negative x to the fourth, right? But no matter what, we have an even number as our degree, right? So what we can see here is we're going to do the exact same thing. So we're going to say as x goes to negative infinity, right? So as we head in this direction, right? I'm going in that direction on my graph. What's happening? My y's are increasing. So my y's are going to the positive infinity, right? I'm going to go the other direction here as x goes to positive infinity. So as we're increasing our x's and we're heading them out that way, what is happening? Let's make that a little bit more clear. As we're heading this way on our graph, what's happening to our graph? It's going up, right? So we would say y is also headed to positive infinity. Okay, when we look at our last one here, this is our negative x squared. Right, we have our x's are going to negative infinity, so we're headed in this direction. What's happening to our graph is it's going down. So that means y is headed to also negative infinity because it's going down. Then when we go to the right side, right, our x is headed to positive infinity. Our graph is also going down. Right, so we have y is headed to negative infinity. So our end behavior defines what happens when x gets really big or really small. So what's happening at the end of our graph. Thanks. You can now work on the silver section of your project. Thanks.